Solving quadratic equations. Okay, reminder, the standard form of the quadratic equation is ax squared plus bx plus c. Okay? Actually, I should have written equals 0 right there. Ax squared plus bx plus c equals 0. A special situation occurs when the b is equal to 0 in the quadratic equation. Okay, the b, if you remember, is right here beside the x. The a is in front of the x squared, and the c is the constant, or the number that doesn't have an x, a variable beside it. So the b is right here with the x. So what we want to see is what happens whenever there's a 0 where the b goes. Okay, how could I rewrite this equation? Okay, I've got 5x squared plus 0x minus 45. How can that quadratic equation be rewritten? Well, what you can do is you can write 5x squared minus 45 equals 0. See, we just eliminated the need for having the x in there because there are no x's. So this is the way we would write it. We would not write this. This is the way we would write it, okay? I just wanted to point out that if there is no x showing, that is because there's a 0 in front of the x. As 5x squared minus 45 equals 0, the quadratic equation can be solved in the following manner. So what we do is we add 45 to both sides of the equation. We bring this down, 5x squared equals 45. Divide both sides by 5. And that gives us x squared equals 9. Then we get the square root of both sides, and that leaves us with x equals plus or minus 3. Because remember, the square root of a number can be positive or negative, because positive 3 times positive 3 gives you 9, and negative 3 times negative 3 also gives you positive 9. So we have two answers for this quadratic equation. It would be x equals 3 and x equals negative 3. Alright, let's look at this one. What's the first thing we would do on this one? Yes, we would divide by 3 on both sides of the equation. That leaves us with x squared equals 25. Then we get the square root of both sides, and that leaves us with x equals plus or minus 5. So we have two answers, x equals 5 and x equals negative 5. So two answers. Number of solutions, 2. Over here we've got m squared minus 36 equals 0. The first step we take on this one is add 36 to both sides. So we add 36 to both sides of the equation. Then we bring down the m squared equals 36. We get the square root of both sides. And that leaves us with m equals plus or minus 6. So m equals 6 and m equals negative 6. And once again we have two solutions. Alright, what's the first step we are going to take on this quadratic equation? Right, we're going to subtract 15 from both sides. Minus 15 on both sides. And we get 3x squared equals negative 15. Divide both sides by 3. Oh, forgot my line. Divide both sides by 3, and we get x squared equals negative 5. And right there is a special situation that you should recognize from earlier studies that we've done. You can't get a square root of a negative number. So that means that there is no solution to this problem. See, this is a negative number right here, and if we were going to solve this, we would have to get the square root of both sides, and there is no square root of a negative number in the real numbers. So that leaves us with number of solutions, 0. Okay? All right, let's try this one. First thing we do, right, is minus 16 on both sides. That leaves us with 4d squared equals 0. Divide both sides by 4, and that gives us d squared equals 0. get the square root of both sides, and the answer is D equals 0. Not plus or minus 0, because 0 is not plus or minus, it's just 0. So the number of solutions that we have on this one is 1. After having done the previous 5 exercises, what can you conclude about the possible number of solutions for a quadratic equation? Let's look back at them. Okay, on this one, how many did we have? We had 2 solutions. On each of these, we had 2 solutions. On this one, we had 0 solutions, and on this one, we had 1 solution. So, what can you conclude from the information that I've given you about the possible number of solutions for a quadratic equation? That's right. You can have 2 solutions, 1 solution, or no solutions, or none. Okay? 2 solutions are indicated on a graph of a quadratic equation by the 2 times the parabola crosses the x-axis. So what you're looking for whenever you are solving a quadratic equation is where the x-axis is crossed by the parabola. Okay, so this one has 2 solutions because it crosses the x-axis in 2 locations. Okay, right here and right here. So your answer on this one, let's say this is a 2, that means this is 1. So your answer would be x equals 0.5, and the other one would be x equals, and over here it would be negative 2.5. So those would be your 2 answers for this one. One solution occurs when the graph of the parabola touches the x-axis in only one location, like this. Okay, this one only touches in one location. It touches at 1. So the answer for this one would be x equals 1. Then finally, there's no solution occurs whenever the parabola does not intersect the x-axis at any point. Because see, for this one's going to go up forever. And this is as low, this is the minimum of the parabola. So it never goes below that. So this is never going to touch the x-axis. It can also look like this and be going forever down. So those are the 3 situations. You can have 2 solutions whenever it crosses the x-axis in 2 locations, like this. Like this. 1 solution when it touches the x-axis in 1 location, and no solution whenever it doesn't cross the x-axis at any point. Graphing a quadratic equation when b is equal to 0. Okay, earlier in our studies we've done x equals negative b over 2a to find the axis of symmetry. So what we're going to do this time is we're going to do that using this. There are different ways to graph and to find the answers, but right now you're going to be graphing the quadratic equation based upon what we have right here, okay? And using the axis of symmetry and plotting the points. So we've got x equals negative b over 2a. What is b? Yes, we know that b is 0, so we go x equals 0 over 2 times 1, so x is going to be equal to 0. Alright? The 1 came from right here. That's the a. Okay? So we've got x equals 0. Now to find out what y is, we come over here to this equation and we set it equal to y instead of equal to 0. We let x equal 0, so we've got 0 squared minus 9 equals y. So that gives us negative 9 equals y. So we come over here and we go to 0, which is going to be our axis of symmetry. Let me see if I can go down this line pretty well here. Not bad, don't you think? I mean, that's, oh. Alright, so that's our axis of symmetry. And our vertex is going to be 0, negative 9, which is right here. And now we need to find some more points. So let's try, how about 3? So we try 3 squared minus 9 equals 0. So that gives us, equals y, sorry. That gives us 9 minus 9 equals y, which gives us 0 equals y. So when x is 3, y is 0. So we come up here to 1, 2, 3, 0. And if we're 3 away on this side, then we're going to be 3 away on this side. And now we've got our parabola. I have such a tremendous difficulty drawing parabolas on this drawing tool here. But there's our parabola. All right, our next one. 3x squared equals 0. The b is going to be 0 again, so it's going to be 0 over 2 times 3, which is going to give us x equals 0. So our line again is going to be over here on the y-axis. We can put our dashed line down it. Okay, and by the way, let's go back over here to this one. How many solutions did we have on this one? We had 2, because see it crossed the x-axis in 2 locations. Okay, on this one, we've got 3x squared equals 0. So we're going to let x equals 0. We put in 0 for x equals y, because whenever you're trying to find y, you just replace the 0 right here with y. So that gives us 0 equals y. So our vertex is at 0, 0. So we come over here and we put our 0, 0 mark. Now let's let y equal 2. Okay, I'm just selecting random numbers. So let's go 3 times 2 squared equals y. So that gives us 3 times 4 equals y, which gives us 12 equals y, which is off our graph. So let's try a number smaller than that. So let's try 3 times 1 squared equals y. That gives us 3 times 1 equals y, which gives us 3 equals y. So we come over here and we go 1, 2, 3, and we'll do the same thing on the other side. 1, 2, 3, and our graph is going to go something like this. It's going to be very narrow. Don't you remember whenever the number in front of the x squared, the a, when the a gets bigger in absolute value, when it gets greater than 1 in absolute value, then it's going to get skinnier or stretched vertically. Okay, and that's what happened to this one. And how many solutions does this one have? Yes, it has one solution that occurs at 0, 0. So the answer would be x equals 0. All right, and on this one, we've got 1/2 x squared plus 1 equals 0. So we go negative b over 2a. X equals negative b over 2a. So that will give us 0 over 2 times 1/2 is 1. So that's 0 over 1 gives us 0. So x equals 0. So we come over here and put our mark on x equals 0. So we take the 0 and we put it in for x, and that gives us 1/2 times 0 squared plus 1 equals y. So that gives us plus 1 equals y. So our vertex is going to be at 0, 1, 0, 1. We select another point. Let's select 2, because whenever you have a fraction, it's a good idea to select multiples of the denominator. So we're going to select 2. So 1/2 of 2 squared plus 1 equals y. So that gives us 1/2 of 4 plus y equals plus 1 equals y. So that gives us 2 plus 1 equals y, which gives us 3 equals y. So when x is 2, y is 3. So when x is 2, y is 3. So we're right here. And I forgot to put the axis of symmetry down the middle here. And if this is 2 away on this side, it's going to be 2 away on this side. So we have our graph now. And how many solutions does this one have? This one has no solutions because it will never cross the x-axis. Okay?